this is it. So, good morning, everyone. And welcome to day 3, or is it day 4 of Autodesk University 2015. And welcome to my session, which is Revit plus more with your Revit, more for your workflow. I hope you were not intimidated with the title, especially this plus thing, you know. It might be scary at first, but it's this thing, you know. Things can be wild in the middle, though. Anyways, just want to know some numbers. Who are architects here? Raise your hands. How about engineers? Oh, contractors or owners? Thank you very much. So, to start with, I would like to introduce myself. So, my name is Homer Anave, and I came from Japan, but I am a Filipino, just like Manny Pacquiao. So, do you know Manny Pacquiao? Yes, one proud Filipino here, you know. Unfortunately, he was just beaten by Floyd Mayweather. And I'm currently working at Taisei Corporation for over 10 years now. And since entering the company, I belong to the BIM Solutions team, which is an exclusive team of our technical design department under the design division. Here, I am very challenged to do difficult but exciting work, especially when it comes to programming and development. So I never stop exploring and the possibilities that my work offers, and I can also do many things whenever possible. But when I'm out of work, I do cycling on cool and warm seasons, skiing on winter, and bowling all year round. I also do some video editing and music composition. So that's all about myself. So here's our class summary for our session. So we already know the basics of Revit, so we have to bring our skills to the next level, as Revit has much more to offer. So we can delve and explore more of its functionalities there. So templates, families, on-the-fly tool development, and utilization are some of those that can make it happen. So here are the learning objectives for this session, but I won't be reiterating this today, but I would like to put these objectives in few words. So we will do here designer's template. We will also having here programmatic workflows with some focus on visualization and viewing tools with Dynamo and Revit API. We will also having interference checking using the interference report files, and also our plan and section detailing. All of this entails you to more customization inside Revit. So speaking about customization, here you will see the customization hierarchy in Revit, with the lowest in the hierarchy being the easily customizable families, templates, object styles, etc., which in our session will be focusing on our designer's template. So then in the middle part, which is visual programming using Dynamo, and the upper part being the Revit API programming, the highest level of Revit customization. So let's begin with our designer's template. So what is exactly this one and how we came with it? So unlike in the Americas, Europe, and other BIM developed countries, Japan is lagging behind when it comes to BIM development. Although architectural designers have acquired knowledge in BIM, especially those young architectural designers, they are still on 2D workflows, and very few of them are dedicated into BIM. Say, for example, we assume our designer here, especially architectural designers in Japan, have received training in Revit, but due to the complex operation of Revit, he becomes frustrated and gives up the modeling work, eventually passing the work to the operator, and then gives the operator some instructions. But if you will try to think about it, the designer does not have the first hand on the model that the projects they are involved. So what we think should happen is that the designer must have the first hand on the models and must be able to operate himself. Having this in mind, we had come up to a solution by which we welcome the designers openly. And this is to create a new template, because templates are the first objects that the user communicates with Revit. So we started thinking how the template must benefit the users, especially pure architectural designers. On the designer's perspective, they must be able to produce models and drawings with the easiest possible way. They must be also able to produce presentable 2D and 3D views. They like the easiest way. And most of all, they must be able to modify the model whenever, wherever, without having the hassles. And in connection with this, make them plan, design, and visualize nonstop while they model. So to summarize up, we have formulated the characteristics of what we will call here the designer's template. So it must give the designer the capability to use Revit as if they are drawing and be able to edit and modify them as quickly as you can. It must be also simple and lightweight. As much as possible, we must not give them the burden that with all the features that the template has. And lastly, it must present organized view and family browsing. You must help them locate the plans, elevations, sections, families, etc. easily with a well-organized project browser. So now that given these characteristics at hand, what to expect in a designer's template. So this template may not be necessarily fully standardized, and it must have a very few everything. So that is line and fill patterns, view templates, family types, etc. and etc. But having only this will not really define the designer's template, at least for our own perspective. So we have to introduce this to our template. Intuitive families. In our experience of creation and utilization of these families, we can say that they are really cool and they make the template so cool. And of course, they must be preloaded into our template. But what are these intuitive families anyway? Let us watch again parts of the videos I showed you in the introduction, but without the BGM, of course. So for here, you can already know the ideas of these intuitive families. So we have here a window, and at once when we select that, we'll just easily edit those properties here, and then of course we can select what type of windows that we want to use. So when we are able to select our own windows, we'll just select the panels that we want to be here as ransom, and then of course those panels that will be in our main window actually. And then of course we can change any time for our own liking, of course. So that will be for our windows. For our doors, actually, it has a different approach with the windows. So in our doors, actually, when we select our doors here, there are checkboxes here that we can select which part of the panel we have to load or we need in those in our doors there. So for example, if you select the louver, glass here, so we have the glass here, including the slit here. And of course, we can also remove the slit so that our glass here will be half full. Half of our panel. And of course, when we select this full frame, our panel here will be full frame. And of course, we can also edit our width here directly. And then when we change our family here, it will automatically adapt those values to the families that we selected here. So of course, we can also change those values and later then. Then, not only windows and doors actually, we have also some plumbing fixtures. So, for example, we just mirrored those pictures from the women's to the men's, and then we'll just edit those quantities here. And then we'll just copy these and then just, change those pictures into other families, and then we'll just stretch the linings we had here. And then we'll just copy there, and then we'll just, change the families there. So you can see that the number of the quantities of our families there were kept while we copy or while we change our families. So that's the power of the intuitive families that we have. So it's really intuitive. So for example, in our 3D model, you can change the materials here. For example, it was previously pink. We'll just type the BLUE, which is a material for our blue there. So So it's just very easy. We'll just create those materials that can be easily remembered so that it will be automatically reflected there. So that will be for our plumbing fixtures. Next, we can also edit this intuitive families using our schedules here. I'm sorry, it must be Japanese characters here, but you can also you will only I mean you will already see those changes that are already reflecting once we check those check boxes here. For example, we had the glass in the upper part, and of course we had this full frame and some slit there. So that will be that's the preview of our intuitive families. So let us discuss the characteristics of this intuitive family. By experience of creation and utilization of these families, we have come up with to the fact that they must be flexible and elastic, stretchable and shrinkable in many cases. It must be easy to edit and modify. The child families in it must be interchangeable too, and must contain basically only one family type. So that's the distinction there. The main reason for this is as much as possible, we don't want the designer to look into plenty of types these families may contain. And if there are too many of them, we will make them search for one that they need, eventually defeating the purpose of an intuitive family and creating our designer's template. So what drives these families to work intuitively? Well, you know some answer? Okay, so those that are driving are, the answer is pretty obvious. It's the shared instance parameters. We create them using instance parameters, but there is an exception, however, that we maintain to use type parameters that or family parameters to some families that we think their use deem wiser. For example, if we need those structural columns on a fixed size, they must be maintained as they must have type parameters in it. Okay, applying instance parameters is pretty straightforward. You just have to assign those dimensions to shared parameters, as well as other information such as an opening number, opening symbol, for example, for our doors and windows. And you also use instance parameters to nested families. But there's one thing that I would like to discuss you in particular. So our one best application of these instance parameters is when we assign them, for example, to a door that has many nested family panels in it. So let's say that in this door we have 8 different panels, and these panels will have their own designated yes/no parameters. So these are the yes/no parameters actually. It's written here. So it has their own unique names. So what's the use of these parameters, and why yes/no parameters? The use of these parameters is to set the visibility of their corresponding panels. These parameters also contain equality formulas holding an integer that represents one or more properties of the door panels, which are flush, with glass, with louvers, with slits, full frame, or inspection door. So we assign each of these properties to our corresponding number, which is a power of 2. What is a power of 2? So we'll be having some mathematics here. Well, it is any number that is a product or quotient of one or several number of 2's. To put it into perspective, those are the numbers like 1, 2, 4, 8, 16, 32, 64, and etc. So why use power of 2's here? We have to remember that any integer is a sum of one or more combinations of numbers which are powers of 2, without any duplication on either of them. Only these numbers can do that. This is the best way on assigning numbers, as the sum of its combinations are truly unique and no overlaps. Looking at the table here, we list here the properties of the door panel, which is here. And we assign each of them a number which is a power of 2. So here's our power of 2's here, to the 0 to the 1 to the second power to the third power, and then there are bit values here. So having these number assignments in mind, let us have some tests here, particularly with these three properties we have. So let's have a first of these three examples. Let us also have a parameter called pk, pk is there, that handles the sum of the power of two combinations. As of now, a flash panel is assigned by default to a number which is 1, currently set when the panel does not contain any glass. If we put a glass into our panel like this, so here's our parameters, power of 2, and here are the checkboxes that are indicates our yes/no parameters there. So when we check that glass, the number in the sum will change, making a total of 2 assigned to our parameter pk here. Excuse me. So in case we want a louver and a glass or a panel, we check both of them. So the values of the louver becomes 4 and the glass becomes 2, making a total of 6, that will be our new value of pk. So this value of pk equals to 6 is assigned to our panel P2G. And finally, say that we want to add all of them. So adding steel, louver, and glass to our panel, then our result will be 14, which will be the value of our panel here, P3G. So taking this into account, we are now ready to assign it into our door family. As you can see here, there are the yes/no parameters here. That's a visibility, not visibility parameters, just a yes/no parameters. We also need to create integer parameters such as glass, louver, and steel, which is over here. That holds the value of the corresponding power of 2 integers. These parameters also contain if-then-else formulas. So those are the if-then-else formulas. And as of now, the values of these integer parameters has 1, 0, and 0 respectively. But when we check these 3 checkboxes here, the value of our integer parameters change, resulting to the number 2, 4, and 8, which are their number assignments. This information will be passed to our parameter pk, which has the formula that handles the results of the yes/no parameters. So the values here will be passed through here, and then in this case we have the values of glass, louver, and steel change. So this portion of pk formula takes effect. So this portion of formula will take effect, eventually leading us to the final value of 14 is there. So let's take this value 14 and look at another set of yes/no parameters, but this time in our visibility group. Okay, here. So by looking at the list, we will notice here that the yes/no parameter P3G has been assigned to a formula that says pk is equal to 14. So this satisfies our condition, and with this condition, P3G is automatically checked. But anyway, and finally, change our door panel there. So that is how we assign and run these parameters in controlling the visibility of our nested families. So the strategy of creating and assigning parameters to our nested families will depend on what kind of family we are dealing with. This kind of parameter assignment is applicable for doors, but it may not be applicable, of course, for windows and even plumbing fixtures. So we have to think carefully how we take care of this visibility, or the visibility of these nested families and their parent families. So that will be all for our intuitive families and our designer's template. So we will next proceed to our programmatic workflows with focus of Dynamo and a very brief stop about Revit API. Excuse me. So let's talk about Dynamo first. You already know that, excuse me, anyone who are using Dynamo here? Okay, so you already know that Dynamo was primarily built for computational design, but as its development progresses, it can be also used for other things, because Dynamo exposes several functions of Revit API or we call here application or application programming interface, we can use Dynamo to manipulate elements in Revit, whether by creating them or by editing them. So this also gives us a way to learn the more advanced Revit API programming. When you are able to catch the flow of the script or produce logics, you may become capable of more in-depth programming. It just requires coding. So, but for this time, I'll just want to show you some of our samples in Dynamo that you can refer or to when you create your own, or you can use for some other Dynamo projects. I'll be showing here our own method of creating the grid and levels, creating our grid and levels, the monumental apple that we have here, the example of pattern creations. In this case, it's a conditional exterior panel layout, and two visualization tools that we have just developed. That's vicinity visualization and a simple program that we call Cabbage. So let's start with the grid and level creation. So we will use the numbers here to set our grids in our Dynamo here. So let's have a demo for that one. So I have here the Dynamo script for creating the grids and levels. So in this portion, we are those that creates the grids, and this portion is the one that creates the levels. So we have our inputs here, but as you can see here, we have already inputted our levels. So it must reflect with our in our Revit data here. So we have, so when we check the north, so it's already created for us. So how does it happen? So to explain what happens in creating our levels, by the way, our method of inputting our numbers to create our elevations for levels are like this. You have this, so all of them are in string values, text values, not numbers actually. So, for example, in upper floors, we have this 4,000 multiplied by 6, and then 3,500 afterwards. So that's our example. So we have to first process here using our string splitting or text splitting. So we split our text here, and then in this portion we will produce this list here. So we have their 6 4,000s and one 3,500 generated there. So we will be using this list actually to obtain the quantity of the items inside the list. So the quantity will be used to generate as a prefix to generate our level names. So here's our count here. So there are 7, and then it will be used to create our level names here, which is 2FL, 3FL, 27FL. And of course, we have to add this RXL because our code block here starts with 2. So it will be just only 6 here, and in addition with that, we'll have this RSL or the roof slab line. So when we have this, when we have created our names for our levels, we have to produce this, get the sum of the per level elevation each for penthouse upper and lower levels with reference to our 1FL, which is graded here. It's here in the bottom. So from this one level, actually, we'll be creating levels with some offsets generated from this sum list by range, which I created. It's a custom node. So from 1FL, when we create our 2FL, it will it will create with an offset of 4,000 millimeters. So I'm talking about a metric system here, okay? Because in Japan we use metric system. So in this, in the second of our list, it is 8,000. So we create from 1FL 8,000 from 8,000 millimeters of elevation. That will be our 3FL, and so on and so forth until we create all of them. And then just generate here our grids using this list combine. Of course, it's also applicable for our penthouse, but in our penthouse, we'll be creating the levels for our penthouse from the highest level of the upper floor. So it will be the RSL. It will we also create the levels from the lower level, from the 1FL, but the direction is different. It's being created below it. So the values here actually will be negative. Anyway, these are the elevations that the offsets, and then the levels are created from the 1FL below. So that is how we create our levels. So here's the portion that we will create our grids. At this point we haven't set our grids here, or our offsets here. So we'll set our offsets here. So for example, in intervals along x-axis, we have this 10,000 times 3 and 5,000. In our y-axis, we have here, for example, 6,000, 9,000, and 5,000. So it is automatically created in our Dynamo interface here. You can see it here. And also it will be created in our Revit model, in our Revit project. So it's here. Of course, there's an option also that you can rotate these grids. For example, if you want to rotate the grids to 30 degrees, so you just type here 30 degrees, and all the grids will be rotated 30 degrees counterclockwise. So I will just bring this back to 0. So the process of creating these grids, especially in the split, in the first process, it's just the same as how we create our levels. The only difference is we use these intervals, not this one. We use these intervals to create our points here. We use these intervals to create our points that will in turn will create our line by 2 points that will be used to create our grid lines. So here's for example, our horizontal grid lines. So here are the points that were actually created in our x-axis, and here are in the y-axis. And then we use these points to create our lines here. So here are the lines, and then we can connect also with the optional rotate here before we create our grid lines from those lines here. So after we create our grid lines, we have to assign them with those names. So those names are actually here. So as you can see here, we have x1 to x5, and in our y-axis we have here y1 to y4. So we can also change this change these values here. So these values can be changed here. Actually, we have this x and y. For example, if we want these to A and B, for example, excuse me. When we set our prefixes for x-axis to A and our y-axis to B, so it will be automatically updated here. So for our x-axis will be A here, and for our y grids will be B. Of course, we can also eliminate these prefixes if we don't want them. So if you don't need them, we'll just select this false, and all those prefixes will be done. And eventually, in our x-axis here, it will be 1, 2, 3, 4, and 5, and in our y-axis will be A, B, C, and D. And when we do that, we'll just change the parameter of those grid lines we have with those strings that we assigned here. Okay, so that's how we create our grid and levels. So next, we will go to the apple. Obviously, it is a complete computational design script, but it's not just something that we play with. This apple is part of our client's request. They want they want a landmark somewhere in a hospital's premises. The hospital is located in Aomori Prefecture in Japan, where it is the haven of apples. That's the reason behind the apple shape. So let's have a demo for this one. Oh. We don't need this one anymore, so we'll just oh, I can close that. So I'll just reopen Revit again. Sorry for that. So here's our profile for a path for our apple, and we'll just open our Dynamo again. So here's our script for the apple that we're creating here. So all we need here is just this curve that will be used to create our apple. So here's the curve, and we'll just select this curve here. Oh, excuse me. And it will automatically generate our apple for a number of seconds. So we have to wait. It won't take a minute, you know. It's longer than what I expected. So, okay, here's our apple that is created in Revit, and also, it is also created in our Dynamo interface. So, let's just have an explanation of how is this produced. So, first we have to get the geometry of that line of that curve that we selected here. And then from that geometry, we'll be copy rotate the path and divide those paths to produce segments. So we produce here the segments, and then we'll just divide the curves by the given number of extract points. So the extract points will be here. Here's 8. So when we enter here 16, the number of curves that will be copy rotated will be also 16, and the divisions that will happen here will also be 16. And when we gather those points, we have to extract some points that we need to create the NURBS curve afterwards. So, as I mentioned here, so we get the end points of the end curves to collect them. So that means we'll get the first point of the first curve. We get the second point of the second curve. We got the third point and the third curve, and so on and so forth until the last point of the last curve. And when we get those points, so it's already here. We'll be creating our NURBS curve, and this NURBS curve will be our path that we'll be using to create our sweep. So one more requirement for our sweep is to create our profile there. So we create our circular profile at the start of the point of our NURBS path, and we'll just create rotated copies of those NURBS path, and of course our circular profile by the given number that I mentioned earlier, which is the value of 8. And also, we have to create the mirrored copies for those NURBS paths and profiles. When we created those mirror paths, we'll just create the sweeps using the NURBS paths and the profiles. So our CPU was created using the original copies of our NURBS path, and those mirrored paths are not yet created in this stage. So when we created those sweeps, we can actually apply colors if we want. But if we want to export them in Revit or in our Revit project, we'll just create a list and then flatten them and then connect an import instance by geometries. So that was happened in our example here actually. Yes.
Will you be making the slideshow or better yet your data set? Will you be making that available, uploading it?
Yes, yes. Actually, the grid and level creation and this app will be available to you afterwards. Okay. Of course, you can also update them or enhance them for your liking. So next will be our, excuse me. Oh, I pressed the wrong button. So next will be our conditional exterior panel layout. This is a sample that was not originally created in Dynamo. It is created actually in Grasshopper. But I somehow partially succeeded in translating it to Dynamo. This is the newly opened Lalaport Mall in Ebina City in Kanagawa Prefecture. Here is a part of the exterior of the mall. Actually, it is the front of the mall. But what I was tasked to do in this project is to generate the patterns on this right side of the exterior of the mall. The designer requested me to generate a wall pattern, randomize a script, and use some result patterns to consult with the clients of the owner or the owner of the mall. But it is not that easy. It was not that easy, as there are rules that are needed to follow. The rules are no adjacent colors on all sides except for the brightest color. Rule number 2, no dark colors at the sides of the blue color here that surrounds our windows. Rule number 3, dark colors reduce as level increases. So in our lower level, there are too many dark colors, but as the level increases, you can see actually that the dark colors are decreasing. As a matter of fact, I have generated 5 patterns for this, but unfortunately, none of them were used here. Anyway, at least I was able to give the script and taught the designer how to change the values of the script so that he can make himself patterns that match his and the owner's liking. So let's just have a demo for this exterior panel layout, but we will just have the first row of the panels created here. So we'll just switch to our demo machine. So here is actually what I did to reproduce our exterior panel creation. Of course, all we need here is just a model curve. But this time I will be using this the longer curve here. So I'll just select that, and it will just easily generate. Oops. Oh, what happened to that? That's odd. I think I just need to retype them. Oh, something's wrong there. Oh, not this one. So here it is. We'll just reselect again. Something's other. So I'll just reset the Revit again. Sorry for that. Anyway, I'll just can explain. So if it becomes problematic again, maybe we'll just skip this. We'll just skip this one. Anyway, I'll just try it again. So, okay, here we are. So here's our result for our exterior panel layout creation. It's just only one row of panels there. Okay. So after selecting the curve, it will just automatically go to our geometry creation, which in this part will be creating our panel. So we have here the curve, and then we'll just divide the curve to smaller curves that has a fixed length. So our fixed length there is it's very small. So here is 600. So we divide this curve to smaller curves which has a 600 millimeters in length, and of course we have to produce points from there. After producing those points, we'll be creating lines for those points, and then we'll just offset the lines or create the lines which will be translated above, and the offset for that is 3,400. So why do I need to have a copy for that? So we need to create some surface there out of those two pairs of out of those pair of lines. So we have this pair of we list a pair of lines here, and using this pair of lines, we'll be creating our surface. So we have to know how many surfaces were created in this in our created panels here. So one reason is that we'll have to assign some panels in some particular colors here. So we have this color volume control, which means that which is controlling the proportion of or distribution of colors of the panels per color. So we can just control here, and when we control that, you can see that the colors are changing and panels are changing there. So when we control that, we'll just pass here to our panel number proportion, which will give us the result of the number of panels that will be using a particular color. So when we are able to establish that, we'll be going now to evaluating our colors here. So excuse me. So this group of nodes here will what I have to say is we'll have this, the rules applied for our panels. So first, when we have those number of panels, we have just to create an indices for the panels out of the total number of panels that we have. So when we do that, first we will have these panels here, and then sort them, and then apply the rules here. So there are two Python scripts here that applies those rules, and when we apply those rules, we'll be able to produce the final indices, which in turn will be the indices that of the panels that will have painted with a particular color. So when we have it, it will produce these panels, colored panels here. So actually, the only rule that is applied here is the rule number 1. So when we have to apply the other rules, we need to create another row above it. So that will be all for our exterior panel creation. You can also apply this or whenever you have this pattern design that for example, if you have a project like this, you can always refer to this one. So that will be all for our dynamo over here, and let's move on to our visualization here. So then next we will concern some visualization analysis. The first one of each is vicinity visualization. In this example, our objective here is how much we view a particular building or mass from a particular area in the ground. To be able for you to understand more of this concept, let me give you one application for this. A particular historical spot in Rizal Park in Manila, Philippines, where the statue of our national hero, Jose Rizal, must capture a beautiful clean scenery or present a very natural scene on its background, meaning nothing in it must be an eyesore. That spot is our viewport of interest here, and the picture of the spot is this. This is the picture of the monument at the Rizal Park, shot from the area where it must capture the clean background view. It's not actually clean anyway, there's a tower here. So this was the spot where you can take the best picture of the monument and feel its harmony with nature, until there's a very tall condominium which is being constructed just within the view from the spot. The name of the building is Torre de Manila. The worst is the construction progressed up to the 46th floor, the highest floor of the building. So the current view of this majestic view is now like this. So the building obviously becomes an eyesore, and this is the Torre de Manila. So with this fate of the Rizal Monument, one architect proposed to construct a huge historically relevant mural behind the monument so as to hide the eyesore building. So this is the proposed design of the mural as the statue's background, designed by a certain Noel Tan of Noel Studio 300. This was actually published in the internet. This is what we'll be reproducing in Dynamo to establish tolerable rough dimensions for this mural wall. So we have this movie here. So that's our script there. So we have five objects to select. First, we have to select the base, which is here. Then we select the subject attraction, will be here, which is here, and our obstruction. So our obstruction will be our mural wall. And of course, we need to select important points, which is our subject face here, and then of course, our subject mass for the view analysis, which is our tower there, here. And when we are able to select the things that we need, we'll just press the run button, and the result will be this one. So as you can see here, the results are in this very opaque red. So it means that in this area, this building is not viewable. So in those areas that are transparent, the building is viewable, and those gradient areas are those areas that somehow you can see the building partially. So here we'll just in this area we'll just display the geometry for our Dynamo interface, and for this area, it's just responsible for dividing the subject face to smaller faces for individual analysis. And the area below here is just for acquiring the valid faces of the subject mass, which is up there, which are not facing upwards or downwards. So we're just having analysis there. And this one node here is just responsible for analyzing the valid faces for the mass from for the surface that we have, and this is actually the custom node, the contents of the custom node. So this takes care of the analysis here that we have here. And so we have to create the gradient colors here, but as you can see, not all surfaces are painted red. So for example, if we want to adjust the dimension or the height of this obstruction, because We can make some so parts tolerable enough to view. So we'll just adjust the height here. And then we'll just reselect our node, our object, and then afterwards, we'll just play the run button. So we'll just have to wait for that. And then when we press the run button here, I can just skip anyway. So here will be changed. Our gradients will be changed here. So in this portion, it was already transparent. It means that from here the building is viewable, and from the areas here, the building is partially viewable. So this may be an error for the movie that I did, but we can always adjust those the walls to obtain the optimal height or the dimension for our mural wall there. So let's proceed to our last dynamo sample here, which is a cabbage. So we call this cabbage. This is a little brother of our main application, Pumpkin, and it is primarily built using visual scripting tools like Dynamo. This is the application for use of design of the stadium of the okay, I'll just skip for that. So the Big Brother Pumpkin actually produces results like this. As you can see in the foreground of the soccer field, that's our subject view. And in the background are the stadium bleachers, where there are lots of colored figures. And in addition to that, we have this gauge here that indicates the percentage of how much they view the soccer field. So the one here means 100%, and the 0.2 here means 20%. So in the processing time that we have here, it just so for those Windows PC with 3 CPUs there, it took 1 hour and 10 minutes. But for the faster in-house computing server that we have, it just took only 13 minutes. So the figure colors have meanings. So that is, I have already mentioned that earlier. The colored red are those who can see the soccer field 100%. While the yellow and green colored figures here can see the soccer field fair enough. But there are those who will say, I don't see anything and I am nothing. And here they are, actually. So knowing that this fatal case, the designers must work something to make these people something. This is how the concept of pumpkin works. But what I'll be showing to you here, actually, has a different approach when it comes to giving the result. Hence, having the name different, which is cabbage. In cabbage, I'll be showing to you how this applies to the sample data model we have, and use a particular viewer to tell us how much it views the screen. So here's a demo for that one. So here's the script that runs our cabbage here. So we have three options, three selections here. So we select the viewer here. And of course, we have to select all the obstructions in front of this viewer. And last but not the least, the subject face, which is the screen here. So after we select those things that we need, we'll just press the run button. And then when we press the run button, it will show here our result. So here's the result actually. So here's the viewer that has a number in his back, which is 76. It means that 76% of the screen is the percentage of that he can view the screen. So to explain what's going on inside, so we'll just here we just display the elements of the Dynamo interface, so which is our abstractions here. And of course, we need to offset the location point of our viewer's eye position because by default, it is here But we need to offset that so that it will point to our eye height. And of course, we need to divide those smaller faces and get the center point of each faces. I actually used the node here by Lunchbox. And then when I establish those surfaces, I'll just extract points from there. And then we'll just create those projecting lines from the eye's view to the points from the surfaces. So when we created those projecting lines, we'll just pass those array to our analysis group here. So we'll just pass the abstractions here, and of course our lines here, and then all will be analyzed from this custom node here. When we do that, we'll just produce the output text, and so it is 76 here. It says here, and then we'll just change the parameter of our object there with a name percentage, and it must reflect. It must be updated here. So we have to connect. We have to add another geometry node here just to make sure that that our geometry in our Dynamo interface will be updated. So for example, if we want to adjust this height of this viewer, for example, because 76% is not enough, so we need more here. So for example, if we adjust the offset to 175, and then when we reselect this model element and rerun the program again. So it will be updated to 95%. So he can see 95% of this screen. So that will be all for our cabbage, actually. So I have just demonstrated you the Dynamo scripts. So you can always extend this to other things with your liking. But Dynamo actually releases more than what you know. But if you think Dynamo is not enough for you, why not take it to the next level? So you can always try Revit API programming. I will not talk about a pure programming here. I don't want to scare you here. I just want to have some brief explanation about its requirements. So developing programs may take knowledge in C#.NET or Visual Basic.NET, but when you have it, you'll be able to learn Revit API yourself. Also, you do not need to be a Revit expert to develop programs in Revit. Take it from me. I myself started to develop programs with a near intermediate knowledge in Revit, and I'm not totally a Revit expert until now. And I come from a C++ environment, and I just learned C++ when I was tasked to develop programs for Revit. So don't lose hope. If you're interested, or if you're a pure beginner, it might take months to learn it, but you will progress as you develop programs. So it's just a preview of this. Of the screen of the program that I'm developing. So the benefits of the ability to develop programs in Revit will take you to create very useful programs, such as those that I'll be showcasing you right now. So we'll be discussing here interference checking and plan and section detailing with compound structures, all created with Revit API. So let's proceed to interference checking using our interference report files. So what is an interference report file? This is a file with an HTML format that is also an output file when you perform interference checks within objects or between objects on the project model and the linked model. This can be acquired when there's an interference report. Here's the interference report, and you'll just press the export button there, and there you can have your HTML report file, which can be viewed from the browser. But have you wondered where it should be used next? Anyone? Any ideas? Yes? You have ideas? So anyway, the basic approach for interference checking inside Revit is best when you have linked models to check with. But once you have exported the HTML file, chances are it will only be just another document for Revit and nothing else. So that will be the dead end, unless you use them in Navisworks. But come on, you can use this in Revit too. Well, you will think it's just it is by using an add-in. Unfortunately, yes. So we need add-ins here to read the contents of the interference report file and do something with the results it will give us. So let's have a demo for this one. So let's make them Revit documentable. So here's our example for our interference report file, for interference checking. So I already assigned here in our project, sample project here, an architectural model with a structural model linked in it. So you can see it here in our managed links here. And we'll just run our tool here we call generate class views. So what this does is create red spheres and then position them to the points that where the interference happened, and of course it will create 3D views for them from them. So we'll just select the HTML file that we have, and it's not a very long process regarding this project. Oh, and that's not 16/13. So our class report is completed. So the results are actually here. I already mentioned this already, a while ago. So here are the class views that we have. The red spheres that is located at the points where the interference had occurred. And of course, not only that, we have also created our 3D views here. For example, in this 007. So we have here the portion where the class views was happened or occurred. So when we have this 3D views created for us, we have to, of course, isolate those elements that are actually interfering or clashing. So we need another command here, which is isolate clashing elements. So we just pick that, and we'll just leave us the elements that are actually clashing. But in this case, actually, the link I cannot leave only the elements of that are clashing from a link model. So I'm still working on for this one. So when we have this class views that we have here, we will next document them. So when documenting them, so we have to lay out the interference checks used for documentation. First, you just make sure that all the class views show clear views of the clashes. When you're done with that, you may want to have a key plan or showing the areas of interference, something like this. Actually, this is a different project. It is a very recent project. Actually, we have in our office. It is a condominium project, and it shows actually the red spheres here. So there are two sizes of red spheres here. There's another smaller red spheres there actually. So when you're done with that, you may want to have So you can do it using sheets to lay them out. So the red spheres are indexed, so you won't lose your way on specifying the marks. So here are the sample layouts or views that created by my colleague here in Taisei. She actually did very well in this, creating these views. So we use these views actually to submit to our designers or to our engineers so that they can actually talk and decide on what to do next. So I just like to highlight something about this thing. So this is also created actually by another command. It actually creates what portions must must allow those pipes pass or not. So in these red areas here, that indicates that no pipes must pass that areas. On the contrary, these green areas are those areas that allows the pipes to pass through. But in this case, these two pipes are actually failed because it's passing underneath the smaller beams there. So So by the way, I also have the Dynamo version of this one, this generate class views, but it just fails because Dynamo does not recognize getting elements from the element ID. So there are some Dynamo programmers there that actually offers some nodes that that gets elements from element ID, but actually all of them are failures. So this is the only thing I'm lacking, but it will succeed here in the near future. I hope Autodesk will address that problem. And when I succeeded, I would like it to share it to you. Okay, some recommendations, however, for interference checking, especially when we are having work sharing projects here. So first, we have to disintegrate the project file from the central file. So the purpose of that, so if you don't do that, you have to perform interference check and export the interference report every time you open your project. This is because the IDs of the element always update when you're reopening your project. So your old HTML file will become invalid after the update. So you will also have to save your project under a different file name, just in case. And bind all link models. So this is the idea if for example, an architectural team's Revit model and the structural team's Revit model do not have a common origin or orientation. Actually, this case is eminent in our design office because in our office, the structural team and the architectural team does not coordinate with regards with the producing the Revit project. So, for example, we have this team that the architectural Revit team produces this project in this orientation, but the structural team actually produces the project in a different orientation. So it is rotated in 90 degrees. So when I am conducting those interference checks, it was really difficult. So the solutions that I just discovered is just these articles that I have given to you. So that will be all for our interference checking. So the last will be our detailing your models and drawings. So in this part of the session, we will tackle plan and section detailing using compound structures. But first, let us review what our compound structure is. So compound structure is a property that exists in walls, floors, ceilings, and roofs, and you can access it with the Edit Type button, and you can see it under the Constructions group. So you know that already. So here is the image of the window when we enter the compound structure property. So here you assign the layers and the materials and all the functions and their thicknesses. You do this every time you want to define a configuration example of a wall type. This workflow may be tolerable if you have just a few types to work on, but it will be tedious when you have to do many. So that is because you are doomed to a repetitive task of composing different configurations of compound structures per type, and you have to do many mouse clicks, and you have to use frequently your type selector. So actually, most companies in Japan, including ours, do the configuration of these, especially walls. So in order for us not to suffer in this repetitive task, we develop programs that I'll be showing you now. So here's the set of programs that I have here. Actually developed this set of programs since 2011, but I changed the configuration in 2013, and those are outsourcing offices and our temporary employees are using that program. So we introduced this program to our Revit modelers and outsourcers since 2 years ago. And what they say about it is what I will guarantee you here. They never used their type selector, and they never pressed that edit type button again. So this will just make you concentrate on configuring the wall types and not let you mind those types that are being created for you. So let's have a demo for this one. So here's a very straightforward sample model. It's just a four-cornered space with the interior wall inside, and it's already have a configuration of the interior of this in this wall. So we also have a wall tag here that we use oftenly in Japan. So we'll just press this edit wall type, and then we'll just edit these walls, for example. And here you will configure your walls, so your wall types. So excuse me if those characters are in Japanese, but anyway, here is the structure of the core layer of our wall, and the outside portion here, in this part next here, has the substrate and the finish. Also, it also has the inside here, in the interior side. So, for example, we want to set the thickness of our reinforced concrete or RC to 200 millimeters. And for example, if we want to set our substrate to non-compressible GB to our 12.5 and our finish to wallpaper, and we also apply here to our interiors, the interior side. And when we press OK, it will just produce our walls here. So these walls are already configured with what we set earlier. So I will just have a view of what happened inside here. So I'll just just show you. These are the wall types that were created with the command earlier. And when we try to enter the properties here, so it is the program did the work for us here. So you have the structure here and the finish here, and for the layers that don't have the thicknesses, don't have thickness, we'll just set the function to membrane layer. So, for example, if we want to change the configuration for this one, excuse me, I forgot. It also created our wall tags here anyway. So, for example, if we want to change the configuration of these, there's no problem. So, what we'll just do is select the wall again, and then just press this edit wall type, and all the configurations that are inside that are in that wall will be reflected when we press that edit wall type command there. So, for example, if we want to make this 2 plies of non-combustible gypsum board and semi-combustible gypsum board, and when we set this to some decorated silica board, and we'll just reflect those configurations from the exterior to the interior, and when we press OK, it will be just reflect here. So not only we do here in plans, we can also do in sections actually. So we'll just go to the view and then apply it here, for example. So for example, we set another configuration here. Then we'll just press the same button and then we'll press OK. Oops, I have forgot to input the size here. So the walls will be configured as well, the stacks will be input. So this program is actually the heart of our all of the programs that it is being introduced here. But there are some programs that are very interesting or very usable here. For example, if you want to put wall tags here, just press the wall and just press the part where we have to configure to place the wall tag. I think I have to change this so that you can see that the position of the wall tag will be correct. I'll just change something here. I'll be changing the exterior part. So for example, we have H here, and then of course these values will be changed also. And then when we click this tag inputting, so the side of this this wall will be adapted with this wall tag that we have here. So of course, if we want to change the materials or the settings for our walls here and for our details here, we have this export materials using Excel. We'll just press this button and it will just export all the configurations and materials in Excel. So to explain briefly, this is the materials. This is the material list that we created. You can always modify this one actually, and of course you can also adapt this drafting and model fill patterns, and then copy and paste here, so that will be reflected to our material when we import them into our project. So other than that, we have this wall structure, wall substrate, and wall finish configurations, as well as also our ceiling and floor materials here. So I guess that will be all for our detailing. So let's have a wrap up for this one. So designers template will be a revolution for designers. So what do you think? And then next, the more you customize with your Revit, the more flexible Revit will be for you. And of course, this generation is a dynamo generation now, so be active anyway. So in the last, I might be reluctant for this one, but try considering programming with Revit API, because more and more capabilities will be unleashed when you start programming with Revit API. So that will be all for our session, but actually I'll be, so regarding the tools that I presented here, so regarding this Revit API tools, for example, this inst type converter, actually I didn't demo this one, but I put it in my blog that I am writing here, it's here. I have this blog, I'm not that active in blogging actually, because my company doesn't allow us to blog for some network security reasons. But here's the procedure actually for bridging your design template for your activity families, just in case you want to work on you want to have a transition from the designer's template to your usual template, so that you can continue on with your working design. So this is the blog this is my blog, and there are the instructions there. Of course, let me go back to the original slide. So it's available at the link from the QR code that I will be showing you later on. So regarding this, the generate clash views and isolated clashing elements, actually it will just be possible, will be available at the Autodesk App Store, and the release dates actually will be in second quarter of 2000, I think next year. I'm still not sure, so I just wrote it still be negotiated. But for the dynamic scripts that I demoed, for example, the grid level creation Apple, it is also available at the link of the QR code that will be yes, it will be available for you later on. So it also includes the custom nodes that I used. So if you have some feedbacks regarding my session, please visit the service stations or email or mobile device, and you'll also having those passes will be awarded daily, actually. So please give us your feedback. So, you have questions? Any questions? So you can, yes. Yes.
You are duplicating the types or creating also types new types?
For example, if when there's a type that is not available, a new type is created. But if the types are available, it will just copy these types, and then it will just be adapted to the wall. Yes, yes. Yes, yes. First it checks the type, the available types, and when it's available, it will just use the type. And it's not available, the program will create another type for those walls. So, any other questions? So it's none. So thank you very much, and on behalf of Kaiser Corporation.